So even though we basically considered a numerical example for the past three sections, let's take a look at another one here to make sure we have all the concepts solidified. In this example, we're going to take a look at four nodes, four web pages in this web graph, and we have a series of 7 hyperlinks. We're going to assume that theta is 0.5, or that we have 50% randomization, meaning that 50% of the time we're actually going to follow the graph we're making our decisions as our random web surfer, as we considered before, on our computer. And 50% of the time we're just going to jump to random nodes throughout the graph. All right, so first thing we want to do is write out the equations for spreading the importance score. Just make sure we have that down. So if we take a look at node 1 first, node 1 splits two ways. First over to node 2, and also over to node 3. So this becomes P1 over 2 and P1 over 2 on each of these links. Node 2 spreads to node 3 and to node 4. So this becomes P2 over 2 and P2 over 2. Node 3 shares its entirety with node 4, so this just becomes P3. And node 4 splits evenly amongst nodes 2 and nodes 3. So this becomes P4 over 2, P4 over 2. So now, why don't we try to write out the equation for the first node? Let's take a look at what's going on. So, for all these nodes, when we calculate the importance score, again, we want now half of this graphical component, or graph, plus half times this random component. And so for node 1 doesn't have any in-degree at all. There's no nodes pointing into node 1. So therefore, the only way we can arrive at node 1 is when we're randomly surfing and randomly entering those URLs into our browser. So P1 is going to be entirely based on randomization, which, as we said, is going to be 0.5 times 1/4, since there's 4 nodes, which is 1/8. So we already know P1, and we haven't even solved for any of the other importance scores yet. So we're doing pretty well so far. All right, now, let's consider the other nodes. Looking at P2, we see that P2 receives from P1 as well as from P4. So, weighting the out degrees accordingly, we have P2 is equal to 0.5 times P1 over 2 plus P4 over 2. And then we have another 0.5 times 1/4 for the random component. Now if we simplify that out a little bit, we get P1 over 4 plus P2 over 4 plus 1/8, which is equal to, substituting in for P1, which we found to be 1/8, we actually get 132 over here plus 1/8, which is actually 5 over 32, combining like terms, plus P2 over 4. And so, I'm sorry, P4 over 2. And that is our equation for the importance score for P2. So now, how about node 3? Well, node 3 receives from P2, from P1, and from P4. So P3 is going to be equal to 0.5 times P1 over 2 plus P2 over 2 plus P4 over 2 plus 1/8 again. The extra 1/8 randomization. So if we simplify that out, again, this P1 over 4 is going to become 1 over 32, as we know, because P1 was 1/8. P2 we haven't solved for yet, so we're just going to leave that as P2 over 4. And again, we also have not solved for P4 yet, so we'll leave that as P4 over 4 plus 1/8. So this is going to be 5 over 32 plus P2 over 4 plus P4 over 4. And then we can write an equation for P4, and we can say that P4 is equal to, as P4 gets from P2 and from P3, is equal to 0.5 times P2 over 4 plus P2 over 2 plus P3 over 2 plus 1/8 for that randomization part again. And this actually should be just P3 because we're not dividing by 2 with the P3. So this is 0.5 times P2 over 2 plus P3 plus 1/8. And if we simplify that out, we have that P4 is equal to P2 over 4 plus P3 over 2 plus 1/8. Okay, so now we've equated all of our important scores, written out those equations. So we want to use our sum to 1 constraint again. P1 plus P2 plus P3 plus P4 has to be equal to 1. And again, we already know P1, so we're already doing pretty well. We just have to find P2 and P3, or P4. And again, we're going to choose to get P2 and P3 in terms of P4. And so, if we look at the equation again for P3, we have that P3 is equal to 5 over 32 plus P2 over 4 plus P4 over 4. And we can substitute in for P2 into this equation because we know what P2 is in terms of P4. So then we'd have P3 entirely in terms of P4. So we add 1/4 times this equation for P4. So this becomes, this P2 equation right here becomes 5 over 32 plus P4 over 4, because remember, that's exactly what we had before, and this is the equation for P2 right in here. This is what P2 is, plus P4 over 4. And so, if we simplify this out, we get 5 over 32 plus 5 over 128, which is 32 times 4, plus P4 over 16 plus P4 over 4, which is 5 P4 over 16, which is 25 over 128 plus 5 P4 over 16. Okay. So now we have P1 plus P2 plus P3 plus P4 has to be equal to 1. And we know P2 in terms of P4, again, just by that simple equation that we had before. And we just found P3 in terms of P4. So we have 1/8 for P1 plus 532 plus P4 over 4, which is the equation for P2, plus now the equation for P3, which is 25 over 128 plus 5/16 P4 plus P4 has to be equal to 1. So now if we simplify this out, you can use a calculator if you'd like. We'll stick with fractions here. We get 61 over 128 by combining this 1/8, this 532, this 25 over 128, plus 25 over 16 P4. 25 over 16 is 1/4 plus 5/16 plus 1. 25/16 has to be equal to 1. And therefore, we can conclude from this equation that P4 has to be equal to 0.3350. Now, solving for the rest of the importance scores is really easy because we know already that P3 is equal to 25 over 128 plus 5/16 times 0.3350, which is equal to 0.3 exactly. And P2 is equal to 5 over 32 plus 0.3350 over 4, which is equal to 0.24. So we have the highest importance score being 4, second highest being 3, the third highest being 2, and the last highest being 1. So just like before, we have 4, 3, 2, 1 is our ranking, except the exact scores are different. And so here's the end result. If we looked at just in degree, we would have had page 1 having an importance of 0, because again it had no in degree. We would have had page 3 being the almost doubly most important, double the importance of 2 and 4, which are both tied, and again 1 being last. But now we have 4 boosted up to the top with PageRank, because again, in degree does not take into consideration the importance of the web pages that are actually connecting to the web page that you're talking about. And in second place, we have P3. Third place, we have 2. Fourth place, we have 1. Again, if you look back at the graph, it should make sense because 3 spreads all of its importance to P4, and 4 also takes importance from 2, 1/2 of P2, as a matter of fact.